Welcome to Study Loop.
All right, for this question, we're being asked to basically show our understanding of the hydraulic cycle and the different components of it. So here I've replicated a very simplistic version of the hydraulic cycle. So here we have a river or some body of water, and water is evaporated into the atmosphere where it condenses into clouds, and those clouds, once they become condensed enough, uh, begin precipitation in the form of rain or snow or sleet or hail, and that falls back to the earth and returns to the body of water. And occasionally there are other steps depending on the environment. Like here I've included a tree to show transpiration, which is when plants release water into the atmosphere, as like evaporation would happen from a body of water. So as we can see here, one of our answer choices for this question is already given to us, evaporation, C. And we know that evaporation is not what is given in that definition in the question itself, so we can go ahead and cross that off of our possible answer choices. But that leaves us with three other possibilities, and of those three, there's one that might sound a little unfamiliar, and one that sounds very close to evaporation that we will talk about first. So first up, I think a lot of people might be wondering, what exactly is residence time? Residence time is actually a measure of the rate at which water, or any liquid really, but in this context we are talking about water, leaves a reservoir or a body of water, basically. So let's say this is a lake, there's a river running into it. River enters this body of water at a certain rate, and it exits this body of water via evaporation at another rate. And residence time basically measures how much time on average a particle of water would be expected to stay in this reservoir at all, which, based on what we are given in the question itself, it doesn't have to be a freshwater body of water. It's not measuring, or it's not discussing something that's flowing into a body of water. It's both in and out. It's a measure of a rate. So residence time, which is option A here, we can go ahead and cross off. But that leaves us with another option, sublimation, which sounds a little similar to evaporation. So you might be thinking, well, evaporation, sublimation, it sounds like it's part of the water cycle. Maybe sub is a key of something going on the surface or under the surface or something like that. Sublimation is actually a different type of process where a solid state is converted immediately into a gaseous phase. So here I have imagine a block of ice immediately became water vapor. That is sublimation, which is not what we are looking for in this problem. So D is not correct. That leaves us with surface runoff. And so let's think about what surface runoff implies. I'm sure you've experienced a heavy rainstorm or been in the aftermath of a snowstorm and the ice starts to melt and the snow starts to melt, and you look around and you see puddles of water on like areas of grass, or the ground is suddenly very muddy and it seems like there's a lot of water everywhere. That's because after a certain point, it becomes very difficult for the soil to actually contain any more water, so that water stays on the surface and begins to enter nearby bodies of water. So here we have a little hill, and as the rain comes down, it is too much for the soil to absorb, and it enters the river. So this is how you get rain and snow melt off entering bodies of water in the aftermath of a storm. And this is important because surface runoff can be involved in soil erosion. It's usually the biggest cause of soil erosion. It can contribute phosphates and other nutrients to certain bodies of water. It can also carry pollutants, so that's something that conservationists are very interested in. And surface runoff, depending on the area, can actually contribute to flooding. So this is why it's a very important term to know when studying ecology. And as a matter of fact, it is exactly what this question's definition is looking for. So our answer is B, surface